Hmm. Yeah, he's recording. Okay. So, yes. Okay. So today we'll look at different um, applications of 3D modeling. So, yeah, let's get started. So I'll use this object to discuss today's lecture, or say today's topic. Um, yeah, let me make a new file. I will use the standard ISO file, or you can use the 3D template. But I'm just going to start with the 2D one. Okay. Uh, so let me sorry. Let me make a couple of layers. So say uh, maybe I'll use 3D object layer, and yeah, that would be sufficient. That is now. So let's get started. Okay, so this is what I'm going to do. So by looking at first when you get an assignment like this, so always spend couple of minutes observing the object, observing the whatever the geometry that you have to model. So here, let me, so if I got this assignment, so what I would do is, um, okay, let me take a snapshot and go to paint on the way top there, but it is useful. Um, so what I will do is I will first uh, model this region without any hole. So if I go to the PDF file, so you will see that um, if you forget about these internal holes, so up to this point, it is the same cross section. So first I will model this um, hatch region as one solid object. Then I will add the behind whatever this section at the uh, back side of this section, and yeah, then I will remove the holes and complete the object. So in order to draw this hatch region, I will use an extrude because the cross section is uniform and and the cross section is sorry, and the height of the solid is perpendicular to the cross section. So yeah, if you remembered last week's lecture, sorry. If you have those kind of properties, then you can simply use the extrude command to model that particular object or part of that object. And afterward, I will use the same extrude command to get the bottom part, to this region. Okay, so yeah, that that's going to be my approach here. So let me drop this snapshot and change the layer, and let me take the line command and start tracing. So I will start with somewhere here. It doesn't matter. You can start anywhere, but yeah, this is what I chose. So 25. Sorry, I will go in this direction. 30. Then okay, 25. Okay. So let me divide into two viewports so that I can see this view and that the object I'm drawing. Uh, yeah, that would be fine. I'll take the line command, start here. um, this length would be how much? 200. So 200, 170. So this should be 70. This side is, the thickness is 20. So yeah, okay, I'll just draw it here, something like this, and draw a vertical line. No, I will use the offset command. So this is 75, 75, and so this is, so say move this one by, so the radius of this outer arc is 50, right? I will move it by 50. Yeah, that would be, let me extend and apply a fillet here. I should have applied a fillet with correct radius, fillet radius of 5, right? Something like that. I don't need this line now, so I'm going to delete that. Uh, yeah, so then I will apply chamfer here. Okay. So this 10, 10. The distance option, distance 1 is 10, distance 2 is also 10. I can simply apply chamfer. So now I will make a mirror and get the other side. Right, now you can draw circles and trim. Let me double check one thing before I go with the trim. It is 75, yeah. Okay, so I need to draw this arc. So it should be 100, yeah. You can use the arc command, but I don't like using the arc command in this scenario. So I will use the fillet command and apply fillet. Simple, like that. So it will give me that arc shape. Now, so what I'm going to do is I will extrude this region by how much? 80. Okay. Um, so let me go to the plan. Right. Um, but you can do that. To extrude this geometry, you know that you need to convert it to a polyline, and it should be a closed polyline. Otherwise, you will not get a solid extrusion. Um, so yeah, that constraint is there. But if you are using the press pull command, I mentioned that you don't have the, some you don't have that constraint. So you can simply click inside the closed region and extrude it out. Okay, so I'll use the press pull command because I don't like to use too many commands. So I'm say let's say I'm lazy. Okay, so because I'm lazy, I like to do it. I like to uh, make it simple. Okay, so before that, let me draw the back part as well. So what I'm going to do is I will use the extrude command. Sorry, I will use the offset command. uh, Offset by 170, like that. Then I will use the extend command and apply a trim here. And let me mirror this one. And let me join these two lines and apply fillet. I should have applied the fillet first and then mirrored. Yeah, now I have this. That's fine. Radius of 20. And yeah, I will apply the holes as well. Uh, the radius, sorry, the diameter is 15. And let me mirror this one. Right. Okay, now I can simply press pull. The height is 80. I change the visual style to shades of gray, which I typically use. And you will see me, yeah, you have seen me using this style. Okay. And now I need to extrude this region by how much? 20. So I will use the press pull again and extrude that by 20. So it is very easy with the press pull command. Okay, now I have this, yeah, almost completed part. So you saw how simple it is, right? Okay, now I need to add the remaining features like these 50 millimeter hole and the other thing, these two slots and this hole. So this is what I'm going to do. So I need to draw to in order to cut this uh, 70 diameter hole, I need to draw a circle on this face and use the press pull command. Or otherwise you can use uh, you can draw cylinder, so you can create cylinder here and so that means draw a circle and extrude it, then use this Boolean operation, subtract, to remove that cylinder. Okay, whatever you choose is correct. So both techniques are correct. Um, I'm going to use, I'm going to follow the easy part. So, which is basically to draw the circle here, use the press pull command. So, in order to draw a circle here, I need to change the coordinate system. If you remember last time, there is a command called UCS, UCS. So, I want to align the UCS, or I want to make my working plane this plane over the top of this 3D part. Okay, so I'm going to use the face option and select this face and enter. So you can see the XY grid appearing on that face on this face. Okay, so now I cannot draw the circle. So let me disable. So the problem with 3D, when you are working in 3D, sometimes it will be very difficult to find where the snaps occur. So usually if that is the case, disable everything else. Or maybe use shift override or what you call, sorry, shift right click and use the snap override settings. So whatever you like. So I'm using, yeah, I disable I disabled all the other snap options and selected only the center. So then I'm sure that I will not be touching anything else. So diameter of 70. Yeah, that's how you do it. That's how I would do it. Okay, now I need to press fully and the depth is 50. Okay, 50, enter. Okay, that's fine. So it went in the other direction. So if this is the case, uh, okay, I will undo. If this is the case, undo it. Okay, let me do it again. Press full. Now this time I'm going like I I tell AutoCAD that it should be downward. So if the first try doesn't work, so what I would typically do is I would zoom out and extrude. I will show the software um, that so I will simply make it obvious for the software that this is the correct direction. Okay. So maybe in the last previous time I was somewhere here, maybe that might be confusing for the software. So in this case, now it should not have an issue. I hope. Okay. Okay, it is not working. Right, that's fine. So then I will use the conventional practice. Extrude, select the circle. Height is 50. Let's see. Okay, right. So I'm going to go to properties and type -50. So yes, that would do it. Right. Now I will use the subtract operation. The press pull did not work. Enter. So this should be the object I want to subtract. So in subtract, you select the base object or from what you are cutting. So this is the base object. Enter. Then this cylinder is the region that I want to remove. Select and enter. Okay. So that is the object you get. So now again, I want to draw a circle here and uh, cut that, remove that region. So this time I will draw it here. The diameter is 30. Then I'm going to use the extrude command. So what you need to do is draw it beyond the object like this. And see, so once you do that, simply use the subtract operation. So this is the base object, enter, this is the object I want to remove, enter. So like, okay. So subtract, you select the base object, enter. So remember, after you select something, you need to press enter or spacebar. So that's how you confirm your selection and go to the next stage. So now it is asking what are the objects that I want to remove. So this is the object that I want to remove from the original base object. So and enter. So yeah, that is a rough practice. So what I recommend is always read the command line. So even though now you are somewhat familiar with the software, still I recommend you to read what is on the command line. I still do. So now, okay, now you can see, this back plate and this plate or this object, yeah, they are two different objects. So I want to combine them. For that, I will use the union and select both of these objects. Once you do the selection, as always, press enter. So that will create or that will merge these two objects into one object. So this is one solid now. Yeah. So now I want to remove these this slot. So there are two slots on this side and that side. The center of the slot is like 20 millimeters from this edge, and the length of the slot is 25. So I will assume that it is centered on this side. On yeah. So if you so I want you to pause the lecture and guess where should you draw the cross section and how are you going to the basically what is the procedure to draw that spot. Okay. Um, yeah. Pause the lecture and think about that. I hope you did that. Yeah. So the process I'm going to the procedure that I'm going to follow is I will first change the UCS to this page. Once you do that, then I will draw the shape of the plot. Maybe I will use press pull and cut away the part. Okay. I hope that is clear. For UCS face option, so I want to align to this face. It yeah, I touch the back plate. So I want this to be my UCS plane. Okay, now I will go to the top view. All right, let's draw that one. The first thing I'm going to do is I will draw a okay, I need to um, draw a line 20 millimeters from this edge, Okay, so I'm going to introduce you a command called solid edit. So the command is solid edit. So this is a very versatile command and it has a lot of features that you need. Okay, so solid edit. So edge. So what I did was I went to the solid edit command. Okay, I think I will show you one more trick. If the command is so there is option if you I think some of you are using this one. So this is called dynamic input. So when function key is F12, so you can turn on or turn off the dynamic inputs with F12 or otherwise this drafting setting, this icon here. So once you enable that one, so that everything will be on the cursor. So like if I type something, so it will be typed on the command line as well as you can see it uh, near the cursor. Let's say I will access the solid edit. See, you can see the message near the cursor as well as on the command line. So now you have, like, you can select these options, uh, like, very quickly. You don't need to bring the cursor or type it. So if you like this option, that's fine. Yeah, that I think you are mature enough to learn this one or use this setting. Okay, so I will use the edge option. From there, I will use the copy edge. So I'm going to copy this edge, enter. So you select the base point. I need to enable the end snap. And so that would be 20. Was it copied? It has been copied. Okay. The problem is the direction is wrong. Let me try it one more time. Uh, Solid edit. Option edge, copy, select the edge, enter, select the base point. For the second point, so let me type at, uh, okay, at 20, 20, sorry, minus 20, comma, 0. Yeah. And you have to press enter twice to exit from this command. Okay, so yeah, that's one way to get a copy, and I don't need this line. Right, I deleted the previously drawn incorrect line. So I have this edge, which is the center of the plot. Um, so the plot is 8 millimeter. It has the 8 mm radius. So that means this length is 16. So basically, I would offset by 8. Um, offset that by 8. Um, Let me go to the midpoint. I need to simply cut away this. I need to make it like 25 millimeter. So there are different ways, but I will use the let's say the most let's say most primitive method. So I will move it by, okay, I will offset that by how much? 12.5. 12.5, and apply the trim. Okay, before that I am going to hide the solid, isolate, hide this one. So that it is easy. I don't need the center line anymore, so I can simply trim. So this can happen when you are in an isometric view. So I'm going to use the plan command. Go to the plan of the current view. So trim. Okay. Touch it. And they are touching. Let me use the UCS command again. Time X, but let me trim. Oh, come on. Trim. Okay, fillet is working. I don't know. Trim is not working. So I will use the trim. I'll use the fillet command instead of trim. Fillet with zero radius. So that will give me what I looking for. So fillet again. I'm going to apply between these two lines so that I can get an arc shape. Okay, now I will bring back the hidden object and object isolation. So you right click and go to isolate and select whatever. Okay, now it's all about press pull. Okay, I will not use press pull. I'm going to hide this again. And I'm going to join them to form a, what did happen? What happened? Go to properties. Ah, man, that's not good. That's not good. It should not be a spline. Okay, it should be a polyline. Okay, so let me join them one by one. Oh man. Yeah, the problem is when I try to apply join command, like join these two, so it converts into a spline, which that is bad. So I need them to be a polyline. So what I'm going to do is I will use the command called pedit or polyline edit. So and okay, I'll undo. Okay, so okay, I'm going to use the polyline edit command. Select this line and yeah, it is asking me whether I want to convert that to a polyline. Definitely, that's why I use the command. Yes. Then it is asking what else would uh, do I want to do? So I want to join this, this, that, and yeah, that should convert into a polyline and it should be closed. Yes, that's good. So if the join command is um, giving you something like a spline, you can always use the polyline edit command, PE, for PEdit. So, and convert that into a polyline, then add the remaining segments into the polyline. So, which will give you the desired output. So now I have it. So let me extrude it. EX, EXE. The height would be 20, right? Yeah, okay, 20. Okay. The reason I use the extrude, but not the press pull is because there are two cuts at both sides. So once you have one extrusion, what I can simply do is uh, mirror this component to get the other part. So so for that, there is a command called 3D mirror. And if you go to the modify command, you will be able to actually find the 3D mirror here. So it will be above the 3D align, like two two commands above the erase command. This one, this small icon. So for 3D mirror, you need 3 points, which will define a plane. If you remember for 2D, you must remember actually. For 2D mirror, you need only 2 points, which will define an axis. But here we are working in 3D environment. That means you need to define a plane. To define a plane, you need at least 3 points. So 3 points which are not collinear. So otherwise, that would be a different issue. Okay. So what I'm going to use is as 3 points. Let me use the midpoint of this line, center of that circle, and midpoint of that edge. So that would define a plane which will be going through the center. So get the 3D mirror command, or you can type 3D mirror, the full command. So this is my object to mirror. Now it is asking me select 3 points. So, point 1, point 2, and point 3. So whether I want to delete the original object or the source object, or no, I don't need. So select the no option, and you have the mirrored copy. Okay. So you have like a 3D counterpart of, sorry, you have a 2D counterpart in the 3D domain. Like if you have a 2D mirror command, there is a 3D mirror command. If you have a 3D, sorry, 2D pattern command, there will be an equivalent 3D pattern command. Right, now let me bring back the hidden object, end object isolation. So I can simply now I can simply use the subtract operation. This is the base object, enter, and this is the first object I want to remove, and that is the second object I want to remove. So yeah, so this is the final. I'm going to change the UCS to the world. So this is the final output. Okay. So that is the top. Um, yeah. So we have the 3D object. So if you have the 3D object, what are you going to do now? So okay, before discussing that part, so let me talk about something called gizmos. For that, let me take a copy of this solid. So later I can simply delete that one. Okay. I hope you can see this like what you call triad. So yeah, when you zoom out, it will be more obvious. So when you select an object, you should see the triad. So if you don't see, basically, if you are in the wireframe mode, 2D wireframe, that triad will not, yeah, it will be disabled. It will, it will be automatically turned off by the software. So they will appear in like conceptual anything in other than like 2D wireframe. So 2D wireframe by default does not have it, but you can bring it. Uh, Anything else, any other visual style will contain this triad. Okay, so let me change to shades of gray. So now when you select an object, you will see this triad. So it is called as a gizmo. Um, so if you don't see the gizmo, so go to solid tab and selection panel, and you will see you can enable or hide the gizmo. Okay, so gizmo is a nice way to move, rotate, scale uh, along a direction. Say for example, if I want to move the object along x-axis, so what I do is I click on this red arrow and drag it. So if you know how much you want to move, you can simply type the value, say 100 millimeters, if I want to move it by 100 millimeters, and enter. So you can move the object from the initial location by 100 units along x-axis. And similarly, if you want to go in That is Z basically. So this is Y. So yeah. And the nice thing is you can right click on the gizmo. By the way, the gizmo will be turned off when you don't have a selection. So it will only appear after you select an object. Okay. So always remember that. So it will be automatically disabled when you don't have a selection. So I'm going to right click on the gizmo. Now you have the freedom to change to rotation. So let me change to rotation. So now see, when I move the cursor, it will highlight the axis of rotation. So this is rotating around y-axis, and this is rotating around x-axis, and that is z-axis. So if I want to rotate around, let's say x-axis by, I don't know, 90 degrees, I can click on this red circle and see, or you can simply type the value, say 90 or minus 90. And finally, we have the scale option, so which will be, yeah, you can scale uniformly. So let me, okay. If you are scaling, make sure to disable the snap, otherwise it will be snapping here and there. So yeah, like that. Uh, sorry. So that is my original object, and this is the scale, rotated, moved, whatever I did. Okay. So that is one thing I wanted to discuss. And the another thing is, uh, let's suppose that for some reason, uh, I miss, I accidentally uh, say, so this depth should be 50, but I I accidentally created it as 45 or maybe 40. So if you had done a simple mistake like that, so what can you do? So for those kind of like simple modifications, um, basically, so let's say if I made uh, this as 40 millimeter, that means I simply need to push this back surface by 10 millimeters to get 50, right? So initially 40, now I need to move it by 10. So if you have a simple modification like that, what you can do is you can select the face. If you want to select, by the way, if you click on an object, you will select the entire object. So let me change back to move. Um, but if I want to select just a face or maybe an edge or a vertex, so if that is what you want to do, press and hold the control key. So when you hold the control key down, as you hover, see, AutoCAD is highlighting me different surfaces, different edges and vertices. So let's say if I want to move this back face by 10 units, I control select the face, solid face. Now you can see the gizmo. So what you can do is select the gizmo and move it by, okay, let me move it by how much? 30. So that, yeah, see, now the depth is 30 millimeters. Sorry, uh, 20 millimeters. So center to center distance. So you can see F2, the depth is 20. Okay, so that is a very nice way to do um, say quickly update your solid object. So actually, that is one way to do the surface move. Another way to do that operation is go to solid edit, okay, and select the face option, and now you have like you have different face modification options. Say for example, I want to move the face, this face, enter. Now you select the base point, and now it is telling me to select the second point. Let's say that is, and enter. So it is a nice tool to have. So solid edit, or you can control select a face. Okay. So solid edit. So I want you to explore the other commands as well. Okay, let me go to the face option, like the face extrusion. So, so okay, so face extrude. Sometimes AutoCAD has some trouble in selecting the correct face. Like here, I can extrude that by like 20. So that means by doing so, I can extend the length of this edge or this part of the solid. So solid edit is a very nice command. So you have different options. Like if you go to faces, you get different options. So if you go to edges, you get like a different set of options. And when you go to body, and you have complete different set of uh, solid editing options. Okay, right. It is a nice tool. I want you to explore it. I will not have enough time to discuss each and every feature of this one. So, but it is a nice command. Okay, inside AutoCAD 3D modeling. So if you made a mistake in 3D and if you want to do a quick change, then yeah, this is the tool. This might be the tool that you are looking for. Okay, go and explore the settings, which can help you, which may help you or maybe save your job. And exit. Okay, I don't need that one. Delete. Right. So I have this solid. So how can I get the 2D drawings out of this one? So firstly, you need to go to a layout and format the layout. So I'm going to go to the format. So right click on the layout name and go to the page setup manager. And from there, modify. So you know that this is what we did in previous case. Like you set the plotter, paper size, full bleed, ISO. Let me go with A3 and yeah, that one. So once you format the paper, so click on the layout tab. So by the way, when you go to model, so that tab will disappear. It will only appear when you are in on the layout. So go to layout tab. Now, um, so you go to the current, sorry, you go to create view and from there, select the 3D. So where are the 3D? So in this case, it is in the model space. By the way, if you use software called Inventor, it is a different 3D modeling software. Um, You can browse for the part and bring it into AutoCAD. So yeah, basically they are the same company. Autodesk is the owner of AutoCAD and Inventor 3D. So I don't have Inventor. I have the model is on model space. So I am going to use this option called from model space. Now, um, now, now it is asking, um, yeah, it's basically telling me where to put. It is asking me where to put this. Before that, you need to select what is the base view. So from this drop down menu, so this will be my base view. By the way, it's a different, you can use a different view. It depends on how you have drawn it. Um, yeah, so this is, let's suppose this is my base view, enter. So once you place the base view, AutoCAD will be, as you move the cursor, AutoCAD will be giving you the projected views. So this is my end elevation and that is my plan view. So once you press enter, see, everything is nice and updated. Okay. So as I mentioned last time, so when you move one or the one when you move the base view, the parent views will be automatically moved to align the parent view. So that everything is nice and perfect. You don't have to worry about those um, trivial stuff. So and you can focus on more on your design. Okay, so once you insert into your model, you need to make sure that you have like the center line, the dimensions. Okay, let me bring the center, right? And you need to include like the center lines, dimensions, text. I haven't included the title block and the title block as well. So yeah, that is there. Annotate. So let's say center line. I can select these two hidden edges and create the center line. What is the layer? Yeah, it is the correct layer. Where did it go wrong? Let me try slate. Fine. Yeah, maybe you need to change the. Let me change. I used the wrong line type. No, I haven't used the wrong line type. Yeah, that's fine. Yeah. So what I did was I changed the line type scale LTS to 0.5, which we took care of the issue. Okay, so go to edit and select the edges to where you want to apply the center. Okay, another nice thing about this is, so when you move the view, see, the center lines also follow. So, so I mentioned that during 2D drawing part, that there is another practice of applying center lines onto the layout. So that is, yeah, this is what I was talking about. So yeah, everything will be properly connected. So when you modify the solid, yeah, you will not have any, uh, you don't have to worry about those trivial stuff. Like, so I can simply move it, something like this. And here also I can apply the center. Okay, I think you get the idea, right? So yeah, other stuff are like basic, straightforward. You need to apply it. Um, and also the dimensions. So as always, make sure you have a separate layer dimension, radial line, like that. Radial line and continue at the dimension. So make sure that you are using ISO 25. Let me go to modify like area highlight simplex PTI for diameter, yeah, for radius and so forth. So we're adding the dimensions to the layout, not to the drawing space. So if I go to the drawing space, yeah, you have only the 3D model. So everything else will be on the layout. Okay. So that is basically what we do in 3D. You create the model on the model space and add the views onto the layout along with the text, dimensions, center line mark, center mark, and whatever, title block, and so on and so forth. Uh, Basically, this is the practice that we use in other softwares like Inventor, SolidWorks, NX, Siemens NX, and other software. You make the solid model, 3D model, and then you open a different file for the drawing. So solid will be the 3D object basically will be on a separate file, and your drawing will be a separate file. Okay, and there will be a link between these two files. Whenever the model is updated, it will be automatically translated into your drawing. So that is basically how the CAD works in this. Um, yeah, that's how CAD works right now. Um, yeah, AutoCAD is not the best software to do 3D work, so but it has a lot of useful features right now. So it is not like garbage. So it can be used in a very simple, not simple. You can do complex stuff as well. Yeah, this kind of application, basically. Um, okay, yeah. So that's basically what we do. Okay, I'll show you few more stuff. that can be useful in AutoCAD. Say, for example, um, okay, one more thing I haven't showed you, and that is very important, and it is a nice feature. Uh, in Let's suppose that I want to show like a section view. So what you do? So here there is a command for that one. Say full section. What I'm going to do is select this view, and I want the section. Okay, let me do that one. Section, full section. Uh, Select a parent view. This is my view, and this is my section line. So I want to project, let's say, in this direction and exit. So see, now I have a section view. So what I defined was the section line. That's all. So it is a handy tool. So now I have the section A. So if you did not have the 3D model, you need to uh, do it manually, which can be tedious. And another nice thing is everything will be um, properly aligned. So you don't have to worry about that one. Yeah, and I broke. Um, and there is like a detailed view. Say if you want to enlarge some region, say for example, I want to show the details here. So I can select this view and draw a circle or whatever. You can even draw a rectangle, and so that will be an enlarged view. So it is one to one. You can define uh, the scale if you want. Like what is the scale? What is the letter? And if you want to have like connection between these two circles, so those things you can, yeah, you can control. So what you do is you select the object or select the view and go to the edit view option. And then select whatever the modification that you want to apply. Okay, so yeah, that is the beauty of having a 3D part. So you can, yeah, basically you can do anything with your 3D model. And again, the nice thing is it is always linked to the 3D model. Whatever you do, if you make some revisions in your 3D model, yeah, it will be reflected on your 2D drawing. So, say for example, I I enlarge this hole, or maybe I may reduce the diameter. If I do that on my 3D model, so this dimension will be properly updated. Okay, so yeah, so this is what we do, what we use in CAT. Okay, I want you to explore the other settings. Here, I only show you full section, and you have option called half section. Try that one, and um, yeah, I think you have already learned about half sections in your manual drawing class, so you will understand how that setting works. Um, okay, so the thing that I wanted to show you is, um, so in some industries, they don't like to have for some reason, okay? I don't know why they don't like that. So they don't like to produce the 2D drawing like this, basically on a layout. So they want everything on the model space. They prefer that. Yeah. So as I mentioned, I don't know why, but you might encounter a situation like that. So if that is the case, how are you going to generate your 2D drawings from your 3D model? Okay, for that purpose, um, there is a command called flat shot. The command is flat shot. Okay, flat shot command. So you will be getting a 2D view of your 3D model. Okay, the command is flat shot, and that will bring a dialog box. Um, so I'm going to use the default setting, and it will ask a bunch of questions. So foreground lines, that means outer lines. So what is the color? If you want, you can assign a layer, or sorry, you can set by layer or by block, or you can set a color. And obscured my lines means hidden line. Hope, and whether you want to show the hidden lines or not. Okay, so I won't show the hidden edges, so that means yeah, I need them. Usually keep these tangent edges turned off. I really don't like that. When you have tangent edges, let me discuss what is that. When you have the tangent edges on, so you will, in your drawing, you will see these edges. So this filler arc, so this surface is, okay, let me highlight that. That surface is tangent to that surface. But, and you should, theoretically, you should not see an edge here when you look at this object because it's tangent. But when you enable that option, AutoCAD will draw that line on your drawing. So which can be very confusing if you have a lot of fillets, and uh, there can be prop uh, components where you get a lot of fillets. So yeah, be careful. So usually I don't like that. So I keep that disabled. So let me go back to the flat shot command. So I don't want that. I'll simply disable it. Obscured lines, I need them to be hit line. Okay, now you press OK. Now it is asking for a base point and a scale because the view will be inserted as a block. So yeah, I need that to be 1 to 1. And use X scale, Z scale, dimension. Okay. Um, yeah, that is kind of weird. Enter. So that is the output from the flatshot command. So you have this view. Okay, that is a block. Let me go to the block editor, right click and go to block editor. Block editor, come on, move it from here to the origin. Okay, move it to the origin. There. Okay, so this is the view that was created from the view created by the flatshot command. See, uh, yeah, it has everything similar to what you got here. So then you can simply add the center lines, add the dimensions, and yeah, whatever you do. Okay, so this is how you take this view. So let's suppose I want to get the plan view. Then what should you do? Okay, remember the flat shot, whatever the flat shot command will give you the current view. So in this case, I'm looking at the object normal to the top plane. Okay, so I'm looking at the top plane. So that's why I got this view. If you want to get another view like this view, then you must be looking at that particular view when you are running the flatshot command. So basically, it is giving you the current view. So let me right here. So this is so if I want the end valuation, first thing you need to look at it. You need to look at the end elevation and yeah, it's not end elevation, that is the plan. Okay. Okay. Okay, so I'm going to change the view using the view cube. Probably rotate it. Okay. Okay. One more critical thing. So when you're using the flatshot command, make sure to use what's called the parallel projection. Uh, Okay. So how you change that? So to get that, or you right click and use the parallel. So if you're using perspective, you will not get the correct output, basically. So don't use the perspective. You must be using the parallel. So it is a must, not a should. So you right click on the view cube and select parallel. Okay. Otherwise, you can type parallel. No. Is there a command? No, that's a different thing. Okay, so otherwise you can type perspective and make it 0. So that is same as using parallel. Okay, so perspective, make it 0. So another way is you can right click on the view cube and use the parallel option. So yeah, whatever you like. I typically type the perspective command. I was thinking whether there is parallel command. It is not there. Maybe in future they might introduce that command. Maybe they might not. Anyway, so make sure you have the correct view. So here I'm looking at the correct, I hope I'm looking at the correct view. So now you can apply the flat shot command. Flat shot, create. uh, so let me insert it somewhere here. Okay, so once you add the view, you may have to rotate it. Okay, so that is something you should do to get the correct view. Okay, like that. So if you want the plan view, then you need to go to the top, get the flat shot, create, drop it to the XY plane. So make sure that you rotate it properly. So that is up to you. So the problem with flat shot command is once you generate the uh, Once you generate the view, um, that's it. After that point, it is all your responsibility. So how to align it, how to rotate it, the software does not give you anything. But if you are using the layout, okay, I moved my object. Yeah, that's what happened. Okay, that's it. Yeah, I have to create it again. Maybe I will be able to. Okay, dude. Yeah, so I can simply bring it back a bit. So let me try to move it. Okay. The problem is I was not getting the base view. Okay. I mean, okay, you get the idea, right? So I need to bring back the other views. Yeah, this is a good, I think, advice for you. So draw it at, uh, if you want to do some modification to 3D object, like move, rotate, do it before you create the views. So after you create the views, don't try to move or rotate the 3D solid. Okay. If you do, this is what's gonna happen. Uh, anyway, I'm not going to spend so much time on correcting that one. Yeah, I learned my lesson. Okay, like that. Okay, that should be rotated. Okay, so like this, you need to correctly align your views. So that's what the flat shot command will do. Another drawback of flat shot command is, so if you do a modification your three, sorry, if you do a modification to your 3D object, yeah, flat shot does not know anything about that. So, so that means you need to update manually. So either you generate the views again, or or you update the or you update the block on your own or by yourself, basically. Um, but the nice thing is, if you have used the 3D model to generate the views using a layout, it will be automatically updated and you don't have to worry about anything. So yeah, it is very easy to manage revision when you are using layout rather using snapshot. So snapshot is like it's a good command, but it has limitations. So yeah, use it, know its limitation and use it uh, nicely. I would recommend. Okay. I think this would be all I want to discuss. Okay, I will show you one more thing. If you want to create something like isometric view, say this view, then yeah, you know what to do. So you first change to the desired view, then use the flat shot. Flat shot. This time I don't need the hidden edges, so I will disable that one. Okay, that is the generated view. Okay, yeah, if you need that view, that's fine. I think, yeah, I don't need this view. I need a different view. Okay, so that's how you generate 2D views from your 3D model. I would recommend you to use the layout because there are a lot of advantages in using layout. Um, and we have this approach where you create blocks from, sorry, blocks using the flatshot command. And yeah, you can use it, but I don't recommend that. Um, yeah, that would be all for today's lecture. Um, yeah, I hope you practice a lot. Okay, everyone. Yeah, let's have a nice day. Take care. That's all today.